Hello. In this session, let us have a discussion on what are the various coolants or lubricants used during the machining operation for different materials. In the table shows clearly for the various machining operations and for various materials, what are the coolants are used. Let us have one by one. For cast iron, normally cast iron requires no lubricants for machining. Normally it is machined at dry condition, but sometimes during the reaming operation, animal fat oil can be used. Next, soft steel. In the lathe operations, it requires the cutting compound oil or soap water may be used. So it often used for drilling, and for reaming, again the same can be used. And planning and slotting operations, while machining the soft steel, it requires soda water as a lubricant. Again, hard steel. So in the hard steel, again, the mineral lard oil can be used, and for drilling operations, kerosene also can be used. Then next, brass. So during the turning operations, it requires no lubricants. For threading, kerosene or turpentine may be used, and for drilling, it requires no coolants. And reaming operations, kerosene may be used as a cutting fluid. And aluminium. So most of the operations are carried out with the use of the kerosene as a lubricants for machining the aluminium. So kerosene is extensively used for specifically for machining aluminium material. And for copper, so for machining copper in lathe operations, normally animal fat oil and turpentine can be used. So it also can be used in the threading and the drilling. Again, requires no coolant for machining copper in the reaming operation and also shaping and slotting operations. So these are some examples. What are the lubricants used for machining different materials and for different operations? Next, we have a discussion about the theory of cutting fluid. Next, we discuss about the theory of cutting fluid. So the main objective of any lubrication in the machining operation is mainly to reduce or minimize the kinematic coefficient of friction between the two chip interface. Thereby, the heat is kept in a particular limit. Here, the pioneer of the theory of metal cutting, Dr. Merchant, developed a wonderful theory for the penetration of the cutting fluid during the machining operations. So he suggested a theory for metal cutting, that is theory of metal cutting, also suggested a theory for the cutting fluid. Here he explained in this theory how the cutting fluid is penetrated, thereby reducing the friction. So as per his theory, there exists a many number of small capillaries exist at the tool chip interface. So according to this theory, he suggested a many number of small capillaries exist at the tool chip interface. So it can be depicted clearly in this diagram. Here the diagram shows the tool chip interface. Here at the tool chip interface, there are many number of lines drawn. So it shows the capillaries. So in between the capillaries, the oil is cutting oil that we apply is filled. So let us have a look how his theory is explained. So as per this theory, as said earlier, there are many number of capillaries exist at the tool chip interface. Here, as the chip during the machining operation, the metal is removed in the form of chips. So the chips move on the top face of the tool. Here, as the rubbing action between the chip and tool, as the point contact zone, here creating a capillaries between the chip and tool. So the tendency of this capillaries readily draws in the cutting fluid. So these capillaries are filled with the cutting fluid. Here the capillaries filled with the cutting fluid. So they chemically react themselves to produce a solid film, that is low strength shear film. But at the same time, during the machining operation, there exists a high temperature and heat involved, and also due to the cutting force and the high pressure, especially at the entry of the chip surface, due to the chemical reaction, it produces a weak solid. So it produces a sandwich film between the two chip interface. So again, under the high pressure and the temperature condition during the machining operation, at the nascent chip surface, that is the entry of the chip surface, the solid film again changed to a weak solid, providing a sandwich filling. So the sandwich filling by the cutting fluid just helpful in keeping the tool apart from the chip. So thereby it minimizes at the maximum extent the friction. So the kinematic coefficient of friction is reduced. So there is a application of the cutting fluid. So thereby we keep the heat evolved or generated during the machining under the proper control, thereby having the tool life for longer life. So there is a theory of the cutting fluid suggested by the Dr. Merchant.